1. Hello, we are a senior design team focused on rust prevention. Our design project is an industrial-sponsored R&D project in conjunction with Scheffler. Our project is focused on protecting electric motors from corrosion, specifically the stator coil of an e-motor. The stator coil is made from lamination stacks that are epoxied together. 140 laminations are staked together into a stack, which are then epoxied to form a coil. The issue at hand is that contaminants can get into the air gap between the stator and the rotor of the e-motor. To prevent failure conditions due to corrosion from these contaminants, e-motors must meet two specifications and be able to survive temporary immersion. To combat the resulting corrosion because of immersion, a varnish is applied to protect the inner diameter of the coil. This coating will also need to be able to withstand a temperature of 155 degrees Celsius. This project is a two-part project. First, we will need to assess different varnishes and test them for evaluation against specified standards. After material testing and selection is complete, the team will move into a design phase. The second phase was intended to be used to design an entire manufacturing process to apply the varnish, but due to constraints on the project, the team decided to try and improve the nozzle design to better apply the varnish material.
The team chose 5 materials to analyze. MG Chemicals is the industry standard, but it is a brush-on application. 2 aerosol applied insulating varnishes comparable to MG Chemicals were selected. Seymour Tool and Spray-On EL609. Anti-seize, an insulating varnish with an operating temp outside of the required temperature, was selected to see the effects. A silicone coating, which is not generally used for this application, but has extreme insulating properties, was selected to prove the efficacy of insulating varnishes. The team sprayed e-steel coupon samples with each material. These samples were temporarily submerged in a 5% by weight saltwater solution, then baked at 140 C for 40 cycles at 10 minutes apiece. This saltwater test advances the rate of corrosion and allowed the team to analyze each coating's prevention capabilities. The knife test is an industry standard used to analyze coating adhesion performance. A knife cuts an X into the coating, and then the coating is pried upward using a known force. Strong adhesion is an indication of good coating performance and will help prevent corrosion. The materials were ranked based on the results from a visual rust analysis under a stereoscope and the knife adhesion test. Spray-On and Seymour were the most resilient during the knife test and displayed the best relative rust prevention as well as coating uniformity. Anti-seize and DEI silicone performed the worst in both analyses, which was expected. The team decided to move forward with the Spray-On into the nozzle design.
The number one goal of designing nozzles was to produce an optimized uniform coating that would better suit Scheffler's needs for the saltwater test. The nozzles were designed in 3 iterations based on fundamental fluid mechanic concepts such as Bernoulli's equation, the continuity equation, and one-dimensional incompressible flow. Each iteration began with CAD designs of various exit hole sizes and shapes with the intention of forming different spray patterns. From there, the models were 3D printed using a Form 2 SLA 3D printer on campus. Afterwards, each nozzle was tested for the spray pattern. Observations of the test guided research for correcting designs in future iterations. For example, it took until iteration 2 to produce properly working cone patterns and iteration 3 for flat fan patterns. 3 types of tests were conducted in a controlled lab. An application test was done for 16 nozzles. This test checked for clogging and the ability to reproduce the same spray pattern. Coating thickness was also recorded for posterity and legitimacy, and the saltwater test was repeated for comparison of SD1 samples and verification purposes. The team also decided to bake a second set of samples to see if heat prior to the corrosion experimentation would assist with coating uniformity. These samples were not saltwater tested. The samples were baked for 2 hours at 140 degrees Celsius, which is the operating temperature spec from Scheffler. Nearly every sample in this set displayed significant improvement in coating uniformity and coverage area. Here's an example. Due to pitting being universal in almost every sample, it was used as a metric for nozzle performance. If you look at the picture to the right, it is a before and after image of the baking process.
Nozzles were ranked based on application quality and coating uniformity. Application quality represents the viability of spraying the samples using each nozzle. Clogging, non-optimized spray distance, and inability to reproduce consistent spray patterns. Coating uniformity was checked across all samples and compiled. The samples were checked post-baking and post-saltwater testing. Corrosion performance was also assessed after testing and recorded for posterity and legitimacy. The recommended nozzles are the copy of the original nozzle, a long head converging circular exit nozzle, a continuously converging oval exit nozzle, and a 15-degree flat fan nozzle. The reason the original nozzle is not recommended is that it didn't perform well in testing. This is believed to be due to accumulated varnish in the nozzle and wear during each insertion. The original was used in every single spray test, thus wearing it down. The yellow nozzles are acceptable but are not recommended for this exact application at this time. Further testing would be needed to prove their efficacy. The recommended varnishes are the spray-on and the Seymour in a close second. Spray-on was selected in this experiment and is recommended in future testing. The best 2 out of the 4 recommended nozzles are shown here. They showed the most coating uniformity and had no application issues. These are the nozzles we recommend future students move forward with when considering initial designs. Thanks for listening.